So I'm going to take a look at some exam style questions. We'll kind of walk through each one step by step, and this is also the place where you can get your answers. So you should try doing the questions on your own first and then come here to have a walkthrough and then get the answers. First thing I'm going to do when looking at the questions is I'm going to look at the circuit that I've got here. So it's telling me that a student sets up a circuit below. So this is the information that I've got to use. So this is a perfect example of being given a diagram or being given information and making sure that I understand it before I try and answer questions, which is something that people are not doing very well at the moment. So before I even try and answer a question, I'm just going to dig into this a little bit, and I notice that there's an ammeter. So I can just annotate this if it helps me. I've got a cell with 6 volts of potential difference. And I've got a lamp here, and that lamp has a resistance of 3 ohms. The question is asking me to calculate the reading on the ammeter. So the things that I know that I have in here are V, I've got resistance, which is R, because this is measured in ohms, and I've got A. So I'm now looking for A, which is current, which is measured, which is represented with I. So now I know I'm looking to use a formula which includes all 3 of those things. So it's got to be then V equals I times R. I'm not looking for anything to do with charge or current or time, because that's not given in the question. So I just need to rearrange this equation, and to help me to do that, I'm going to do V equals IR, and then I'm looking for I, so I'd cover that up. So I would equal V over R. So I would equal the 6 volts going in over the 3 ohms of resistance. So then I would equal 2 amps. So the current is 2 amps. And remember, amps is just coulombs per second. When I'm doing the question, I'm going to be extra careful and make sure that I actually write the answer where it asks me to write it, rather than just putting loads of working out everywhere and then neglecting to put it where it's actually asking me to put it. I'm going to move on to 1.2, and in question 1.2 it asks me, I'm picking apart the question, I'm looking at the verb calculate, so I know that there's some kind of maths involved here again, and I'm looking for the charge that flows through the bulb in 2.5 minutes. So now I need to figure out the things that I've got from this question. So I know that charge, I'm looking for Q, which is measured in coulombs. Flows, I'm looking for current, which is measured in amps. And I know that 2.5 minutes is relating to time, which is in seconds. So now I need to employ a formula which pulls all these things together. I know that Q equals IT, current equals, charge equals current times time. So how am I going to do this? Well, I've just calculated the current in the last question. I know that the current is 2 amps, so this is an example of questions that build on each other. So I've got I'll just pop it here. I know that I equals 2 amps, and I know that time equals 2.5 minutes. Now the thing to remember is that time is measured in seconds, so to avoid making a silly mistake, I need to convert this to seconds. To convert to seconds, I can just do it in my head, or I can get my calculator and I can go 2.5 times 60, because there are 60 seconds in 1 minute, and that gives me the answer of 150 seconds. So we're getting quite cramped in here, so I need to find some more space to make it really clear. But my formula, Q equals I times T. So Q equals 2 amps that we previously figured out, multiplied by the 150 seconds that we just figured out. So Q equals 300 coulombs. Again, I'm going to be extra careful and make sure I write it where it's actually asking me to write it. I'm lucky in this instance because it's giving me the units. It says the question's worth 3 marks. Probably get my mark for using the correct formula, doing the correct maths, and getting the right answer. Okay, so the next question, 1.3, is a bit of a word problem. It asks me to do a bit more reasoned thinking. So this is an example of reasoning skills based on things that I know. So let's pick the question apart a little bit. A second bulb identical to the first one. So that suggests to me if it's identical, this is also going to have a resistance of 3 ohms. And then this is, get my highlighter back. This is added to the circuit between the first bulb and the ammeter. So that suggests to me then that they're going to put another bulb here that's got 3 ohms. And remember, the resistance of the total circuit equals resistor 1 plus resistor 2. So the total resistance in the circuit here would be 3 plus 3, and it would be 6. Sorry that that's getting a little bit messy in there. So I know the overall resistance of the circuit is now increased. So in my answer, it says to describe and explain the effect that this will have on the ammeter reading. Well, I know that if I increase the resistance, if I increase resistance, the ammeter, and this is the important bit, the ammeter reading goes down. It asks me to explain what happens in the ammeter reading, so it might not be enough just to say, well, current is reduced. I would have to be really smart about it and say the ammeter reading goes down because current is reduced. And current is reduced because overall resistance has been increased. The overall resistance has been doubled, but the potential difference hasn't changed. So the only other variable that can change is the so I just might want to add the kind of reasoning that I put in here, where I talked about total resistance increased to 6 ohms, so current decreases. You'll have to excuse my poor handwriting, and I haven't got much space to write. I think you guys will have more space on an exam paper to write. Okay, so moving on to question 2. I'm just going to unpack the question again. The reading on the ammeter, oops, let me get my highlighter instead of that. The reading on the ammeter is observed to remain at 1.5 amps, so the current doesn't change over a period of 4 minutes. So I've got this ammeter here that's saying it's going at 1.5 amps of current. I notice here that there is a variable resistor. I know it's a variable resistor because it's the rectangle shape with the arrow through it. So that's something important to remember. And then I've got 4 minutes. Well, thinking back to the last question, I know that Q equals IT. I know that T is measured in seconds. So before I do anything, 4 minutes, I need to multiply that by 60 seconds to get me the number that I need to work with in time. And so I can just do 4 times 6, 240 seconds. I'm now equipped to start answering any questions. And now it's asking me to calculate the charge. Great, so it is asking me to calculate charge, so my thinking was right there. Calculate the charge that flows through the variable in the resistor in this time. So if I'd not made the connection yet, I know that I need to be working with charge, so Q measured in coulombs, flow, the word flow suggests current measured in amps, and time, T, measured in seconds. So I need my formula for that. Q equals I times T. So Q equals the current of 1.5 multiplied by 240. So Q equals 360. So the overall charge that flows through the circuit is 360 coulombs. Next question, I'll go straight ahead and unpack it, and the more you do this, the quicker you get at it. But the PD, I know that PD is measured in volts. It's the potential difference, it's voltage. The potential difference across the variable resistor. So it's talking about if I put a voltmeter here and measured the points between here, the potential difference going through it, it's measured to be 6 volts. So that would be giving me 6 volts there like that. Show that its resistance is 4W. Well, unfortunately there's just been an error here with that there, so as it's been copied into the document, it's not done this symbol. So show that the resistance is 4 ohms. Don't get confused with that W. It suggests that it might be power, but it is actually ohms. It's just the way that it's copied across. It's not copied the symbol correctly. So I know that I've got a formula to do with volts, one to do with ohms, resistance measured in ohms, and the only one that I can think of is V equals I times R. So this question is actually telling me that the answer is 4 ohms, and it's basically now saying prove it. Prove that it's 4 ohms. So let's prove it. Well, we've got V equals I times R, but actually if we're trying to prove the resistance, we need to figure out what R is. So we need to rearrange this equation. So to do that, I'm just going to borrow this space here. V equals IR. Just kind of put the V up there and make our triangle. I'm looking for R here. I want to cover that up. So R equals V over I. So that's the formula I'm looking for. Well, I know what V is. Let me just get rid of this for a second. Can I get rid of that? No, it won't do. So R equals V over I. So that means that R equals our 6 volts divided by the current, which I know to be 1.5. So R equals 4 ohms. So I've just proved it there. So I've just used a little bit of maths to prove that what this is saying is correct. Okay, so the next question is a little bit trickier. So I'm going to have to unpack it again in my mind so I'm clear on exactly what I need to do. So it says the resistance of the variable resistor, which in the first instance we know had a resistance of 4. So initially it had 4 ohms, is then increased by 50%. Now it's asking us to calculate the new reading on the ammeter. So it's saying if we increase the resistance, there's going to be a different reading on the ammeter. That suggests to me then, before I do any working out, if the resistance is going to increase, then this number here, the current, is going to decrease. So I'm looking in my head for a number now that is going to be less than 1.5. So let's go ahead and do this. So I know in the first instance that my resistance was 4 ohms. And I need to think about how to increase by percentages. Well, to increase something by a percentage, so to increase, we're looking for a number that's 1 point something, and it's 50% here, so it's 1.5. So 4 times 1.5 equals 6 ohms. Remember that obviously multiplying by a number greater than 1 increases its value. If I wanted to find 50% of 4, I'd do 4 times 0.5, which would give me 2. That would give me a number smaller. So to increase a percentage, it's an important thing to remember. We'll just increase it by 1 point, and whatever that digit says there. So that's the first part of the question done. That's only a little bit of it, so that might get us a mark. But actually what it's asking us to do is calculate the new reading on the meter. Well, I need to think about this. The reading on the meter, it tells me the amps, which is I. So that tells me that I'm looking for I. So in terms of my VIR formula triangle, I'm looking for I, so I equals V divided by R. So if I equals V divided by R, that means I equals the potential difference, which it doesn't say is changed. So going back to the last question, I know that it's 6 volts. So it's 6 divided by my new resistance here. So it's 6 divided by 6. So I should know that any number divided by itself equals 1. So the current is now 1 amp. Hope that helps. Check your answers against this. Check your working against this. Hopefully in your books you've done it a little bit tidier, or your notes, wherever you've done these. But just make sure that the things to remember are that you're at speed able to unpack the question, looking for key words that tell you what formula you're going to use, but also key verbs which are telling you what you need to do. So unpack the question as you're doing it. Don't forget to unpack the diagram. Make sure you're familiar with what's in there, and that, because that relates to the question. That's using the information. Don't lose marks for that. And then check your working thoroughly. So if I were to do this, if I were going to check my work again, I'd literally go through the questions and do it all again and check that the numbers that I've put in are correct. And then I'd use my calculator if I needed to, and just double check that they're all correct, making sure that I've got units where appropriate. Hope this helps. Good luck. I'll be adding more videos on this week. Keep your eyes peeled, and make sure you get plenty of revision done for your exam on Tuesday, and do your Tassomai.